Welcome to Regents Chemistry Review here at the Phoenix Learning Center. I'm Mr. B. Understanding how to use the New York State Chemistry Regents reference tables is a surefire way of achieving a high score on the New York State Chemistry Regents examination. During this lesson, I will explain how to use one of two New York State Chemistry Regents reference tables dealing with solubility. Reference table F. Solubility is the ability of a substance to dissolve. And in the process of dissolving, the substance that is being dissolved is called the solute, while the substance in which the solute is dissolved is called the solvent. And a mixture between the solute and solvent is called a solution. By the way, solutions are also called homogeneous mixtures. During this lesson, the solvent will be water and the solute will be a specific salt. When salts dissolve in water, the interaction between the positive and negative ions in the salt and the polar water molecules are called molecule-ion attractions. In this example, the positively charged sodium cations are attracted to the oxide or negative end of the polar water molecules, while the negatively charged chloride ion is attracted to the hydrogen or positive end of the polar water molecules. Now for reference table F. Reference table F is divided into two sections. One section lists ions that will form soluble salts, while the other section lists ions that will form insoluble salts, which are salts that do not dissolve in water. Each section also contains a column that indicates exceptions to the rule. For example, most carbonate compounds are insoluble in water, except when combined with group 1 ions or ammonium ion. So solutions containing carbonate compounds will usually have a low concentration of dissolved ions. On the other hand, all nitrate compounds are soluble in water without any exceptions. Therefore, a solution containing a nitrate compound will have a high concentration of dissolved ions. Consider another example, the compound sodium chloride. Sodium chloride contains a group 1 ion. And remember, all compounds containing group 1 ions are soluble without any exceptions. And therefore, sodium chloride will be soluble in water. The presence of the chloride ion only enhances the solubility of the compound. Now for the compound silver chloride. The chloride ion in silver chloride is located on the soluble side of table F, but the silver cation is found in the exceptions column. Since the silver cation is found in the exceptions column, silver chloride represents a compound that does not dissolve in water and therefore is insoluble. So to summarize, if an ion is found on the soluble side of table F and no ions are found in the exceptions column, then the compound will be soluble in water. And if an ion is found on the insoluble side of table F and no ions are listed in the exceptions column, the compound will be insoluble in water. If a compound contains an ion from the soluble side of table F and an ion in the exceptions column, then that compound will be the opposite of soluble, which means the compound will be insoluble in water. And if a compound contains an ion from the insoluble side of table F and an ion in the exceptions column, then the compound will be the opposite of insoluble, so the compound will be water soluble. Finally, at some point during the course, you will encounter the term electrolyte. Remember, all soluble ionic compounds, which are also called salts, by the way, will conduct electricity in aqueous solution. Therefore, these compounds will represent strong electrolytes. and solutions containing insoluble salts will barely conduct electricity, and these compounds are classified as weak electrolytes. This concludes my explanation of how to use Regents Chemistry Reference Table F. Hopefully this video has been helpful. And remember, should you need further assistance on this topic, feel free to visit my Facebook page at facebook.com/WPHS Chemistry. Thanks for watching.
Ayúdame a olvidarla, te lo pido. Ayúdame.